Hi everyone. So we have decided to continue with sorting. So this video is going to walk through the QuickSort algorithm. And it's important to note that this algorithm was developed by Tony Hoare. He's a British computer scientist and it was developed in 1959. So a bit of facts about the actual sorting algorithm itself before we get started. Then over here, I just want to walk you through the legend that I'm going to use for this sorting. Some of these terms will become more understandable as I go through the actual algorithm, so bear with me. So blue is going to be our pivot number. Yellow is going to be the sublist where the values are less than the pivot number. Black is going to be the sublist where the values are greater than or equal to the pivot number. And green is going to be sorted. We are going to start this with the same list that we have used in the other examples for selection, insertion and bubble sort, because I think it's a little bit easier if we're using the same numbers as we go through. So before I actually start walking through this, I want to talk a little bit about the QuickSort algorithm itself. So the QuickSort algorithm, I mentioned it in class today, can be implemented recursively. Now, I know you haven't done recursion yet, but there is quite a simple explanation that I can use in this video. And then when you come back to recursion, it'll make even more sense. So what that means is that the sorting algorithm is recursively repeated on subsets or sublists of the same problem until a specific stopping point is reached. In this case, this is reached when there is only one item left in the list. And we'll see the recursion because it has to be done using a function. And the function definition is part of the code. And the same function is called from within the code. And that's a sign of recursion as well. So this algorithm, it'll start by selecting a value from this list. And we're going to call the value that we select the pivot value. There are several options for this. We could choose, for example, the first item in the list or the last item in the list. In the example that we're going to use, we are going to choose the last item in the list. So you can see that I have pulled that out here, and this is going to be our pivot value. So I'm just going to do the blue around that so that we know that that's our pivot value. I'm not going to write in the words, I'm just going to use the color coding. Because this is a recursive algorithm, it will be written with a function, so we will have to do a function definition. I know that you know what a function is because you mentioned it to me the other day, and that using the function and the list that is to be sorted will be passed in as an argument to the function. So the first thing that QuickSort does is it creates two sublists. The first sublist contains all the values in the list, excluding the pivot value, that are less than the pivot value. So our less than color is orange or yellow, and this is this sublist over here. So this is our sublist 1. So it creates two sublists. The second one I need black for. The second sublist contains all the values in the list, excluding the pivot value, that are greater or equal to the pivot value, in case we have duplicate data like we had today. So we have three things going on here. We have our less than pivot value list, our pivot value, and our greater than or equal to pivot value list. So as we work through this then, we have to get to a stage where everything is sorted. So if I just go to green for a second, I can say that this is the start of my sorting. So it's going to sort from here. And I know I made it blue there a minute ago, and it is still our pivot value. And I am going to make it blue, but we choose it from here as the pivot value. And when it comes into here, it becomes the start of the sorting of the list. You'll notice that if we look at the two sublists, these two, this one and this one, that they're only partially sorted. All the values less than the pivot value being the one circled in green now, are in the sublist on the left, and all the values greater than or equal to the pivot value, which is in green, all the ones greater than are on the right and are in black. If at this point the three lists were to be concatenated, we would end up with a single list that would look like this. Let me get a color that I haven't already used, which is trickier than it might look. Now we'll go purple. I'd end up with a list like this: 24, 45, 17, 31, 50, 85, 63, and 96. So if I was to take the values as they are there and I was to concatenate them to each other, this is what would be returned. And this is not sorted. Because we can see that 45, for example, is ahead of 17, 45 is also ahead of 31, so we can see it's not sorted. Before all three sublists are concatenated, the QuickSort algorithm is recursively called on the left-hand sublist, this one, and the right-hand sublist to sort the values. This means that the algorithm is repeated on each sublist as per the previous example. So I'm going to show you an example of that now. So bear with me. I'm going to clear this out. That was just if we went from there. And if I was to take each sublist now and I was to do this scenario to it, what would that look like? So we're going to take one at a time. Let me just do, we're going to do this one first. So if I am to say what is the pivot value in this list, we choose the last item. So what we are going to have then is my pivot value is going to be 31. Hang on now, the colors matter. My pivot value is going to be 31. Then I have to determine from that what's in my greater than list and what's in my less than list. So I'm going to go my less than list first, which I'll do in yellow. Actually, let me just draw square brackets around that. And then I'm going to do square brackets here. I'm going to do this in yellow. So what's less than that is 24 and 17. And what's greater than that is my actual block list, which is 45. So what I've done is I have my sorted value here. I have my less than pivot value here. And I have my greater than pivot value. My greater than pivot value here. So what I did in this one up here, I've just repeated. So I picked this as my pivot value, this as my sorted, this as my less than, this as my greater than, if we just do the colors. So all I've done is I've taken this list, I've broken it into these three. Now I've taken this list and I've broken it into these three. Now I have to do the same over here. So if I take a pivot value and I do the same principle, it's going to be 96. So I am going to have, I'm just going to do it in green. My 96 is here. My less than is 85 and 63. And my greater than is empty. I really need more colors here. So I'm just going to see this here. So this is my starting list. This is my first set of starting to sort it. This is my second on one side and my second on the other side. And what we have to do is for each list, as we work down, not including the greens, we have to recursively sort them in exactly the same way. So it will look something like this. So you'll see I've added in the numbers, and that's just to save time. So we had come to here. So what I did was then in each list that was left, assuming the greens are the sorted, okay, in this list here, I picked my pivot value, which I said was going to be 17. I pulled it out here to be the pivot value. Because it's going to be the pivot value and it's on its own, it's sorted. that only left 24, which went into my black greater than or equal to list. But because it's an individual figure now and it's on its own, I can say that it is sorted as well. So I did the green around it. And there's no other values to be sorted from that list. I can bring down my 45 because that is on its own. So therefore it is also sorted at this stage. And then over here, I have 85 and 63. So I choose 63 as my pivot. I pulled it out as my pivot, and 85 is greater, so it goes into the greater than list. But because again it's a single value, it's already sorted. So now what we have is, and in fact, instead of pulling this down here because that's duplicating work, we can say that this is already sorted because it's a single value. So what we have to do now is build back up our list in sorted order. So we know we're finished this when all of the sublists have a length of 1. So length of 1, so this has 1, 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 this has 1. So we know that they all have a length of 1. And so there's no sublists left that have more than 1 in it. And what we do then is they're all returned from what will be the function, which we'll look at the code for on Monday. From left to right, smallest to largest if ascending, and concatenate it into one sorted list. So if we go from left over here to right, from smallest to highest, we have 17, 24, coming back up here to this tree. So coming back up on this side, and then we'll do the other side, 24, 31, 45, 50, which is here. And then we come down to the bottom here, which is 63, 85, and 96. It's not entirely super easy to see because I'm writing it on the board, so my writing isn't the best. So I am going to just review this now, but I'm going to have it all typed out. So we'll do it one more time, but this time I'll have it all with the typed numbers, and we'll run through it one more time. Okay, so I'm going to fly to that again. We have our unsorted list up here. This is our unsorted list. Then we pick our pivot value, which is 50. And then what we do is we have our sorted, which is our pivot value, our less than our pivot value over here, and our greater than or equal to pivot value over here, or values that are greater than or equal to our pivot value over here. So unsorted list, we pick our pivot value, goes in here. Left hand side is the values less than that number, right hand side is those greater than or equal to. Then we are going to recursively repeat the algorithm on the sublist. So I've put in this sublist here and this sublist over here. The code won't repeat that, but I'm doing it for ease of use or ease of visuals for us. So I'll do the left hand side first. We pick our pivot value. The pivot value goes in here. What goes on the left hand side is those less than the pivot value. What goes on the right hand side is those greater than or equal to the pivot value. And then we recursively repeat the algorithm again. So this is the only sublist left because it has more than one value in it. So we pull that down and we're going to repeat it on that. So we pick our pivot value, which is 17. That becomes our sorted value over here. This here is our greater than value, but it is also at this point sorted. We go back and do the same over here. So we pick our pivot value in this 96, which becomes our sorted value here. And this is our less than list. This list comes down to be recursively repeated. We pick our pivot value, the last value that goes in here. And then this is also sorted. And then we're going to have to put the list back together. So now we start on the left hand side. So we say this is 1, 2, 3, 4, 5, 6, 7. And that's our final sorted list. 17, 24, 31. I missed one. 51, 45.